Here, our goal is to determine the size of angle A. Notice that angle A is one of the angles that is inside this triangle. Moreover, angle A is on the side of this angle, which is 108 degrees. And so how are we going to determine the size of angle A? Notice that we're going to use this useful geometrical rule, which states that angles on a straight line add up to 180 degrees. Indeed, we have these two angles which are on a straight line and they are at a common point. And so that means that these two angles must add up to 180 degrees. And so their sum is 180 degrees. And so that means in order to figure out or in order to determine the size of angle A, we have to subtract. We take 180 and we subtract it with 108. And 180 minus 108 is actually going to be 72 degrees. And so A is equal to 72 degrees. That's the size of angle A. Next, the question states, calculate the size of angle X. And so our goal here is to determine the size of angle X. Notice that we can often spot interior alternate angles by drawing a Z shape. So let's draw a Z shape. So here we have a Z shape that is drawn. Indeed, if we look here at 30 degrees, and if we look at here at angle X, they are alternate angles. Notice that we have the Z shape, and X and 30 degrees are alternate angles. But what do we know about alternate angles? Here we have, according to this diagram, we have the Z shape, and we have this angle along with this angle. They are alternate angles, and this is angle A, and this is also angle A, which means that alternate angles or alternate interior angles, they are equal. And so that means that if this is 30 degrees and this is X, and these two angles are alternate angles, that means that X must be equal to 30 degrees because alternate angles are equal. Let's move on to the next question. It says, calculate the size of angle Y. So we already know that angle X is 30 degrees. Now our goal is to determine the size of angle Y. Notice, according to this chart, it says that we can often spot co-interior angles by drawing a C shape. And so what we're going to do is we're going to draw a C shape on this diagram. And notice that angle Y and the angle whose measure or size is 120 degrees, these are co-interior angles. And the C shape helps us to identify or locate or spot co-interior angles. So this right here, angle Y and 120 degrees, they are co-interior angles. Now, what do we know about co-interior angles? Notice that we have here this C shape, right? And we have angle G and angle H. They are co-interior angles. And notice that we have here G plus H equals to 180 degrees. And so that means that co-interior angles must add up to 180 degrees. And so if we go here, that means that angle Y and 120 degrees, when we add them up, they should give us 180. They should give us 180 degrees. And so if we want to figure out the size of angle Y, we have to subtract. We have to take 180 minus 120, and that gives us 60 degrees. And so that means that Y is equal to 60 degrees, which makes sense because 60 plus 120 add up to 180 degrees. Next, our goal is to determine the size of angle Z. Notice that vertically opposite angles are equal to each other. Here we have angle B, and angle B is vertically opposite to this angle. Notice that these two angles are equal because they are vertically opposite angles. Here we also have angle A, and this angle A is vertically opposite to this angle, and they are equal. We know that they're equal because they are vertically opposite angles, and they have the same letter. So this is A and this is also A. So they are equal in measure. And this is B and this is also B, so they're equal. And so what we learn is that vertically opposite angles are equal to each other. Notice here we have angle Z and we have this angle whose size is 120 degrees. Z is vertically opposite to 120 degrees. And so that means that these two angles are equal because vertically opposite angles are equal. And so that means that the size of angle Z is 120 degrees.